All right, we are just going over a little bit of the breakdown of the CLEP exam and doing a few practice problems today. So it's broken up into two parts. First part, you get that online graphing calculator, usually around 25 questions in 50 minutes. Second part, usually around 23 questions in 40 minutes, no calculator. You can read through this more in depth if you want to. This page just kind of breaks down what topics are on the exam. I mentioned to the class that some of this might be stuff you learned in Algebra 2, and most of it is trigonometry, obviously what we learned in pre-calculus. You will get this reference sheet, which includes the law of sines, law of cosines. Sum and difference formulas are the only trig identities you will get. Range of inverse function, which feels a little random to me, but it's all right. Okay, so we're going to do 10 sample questions today. We're going to do 5 graphing calculators. I'm going to walk you through how to use your calculator to help you on some of these, and then we're going to do 5 non-calculator ones. Okay, if I go too fast through these, I would be happy to show you them in class. So first one, we have a rectangular tabletop. The width of the tabletop is 3.5 feet less than the length. Okay, we know the area of this is 24.5, and they want us to find the perimeter. So here's what we know. We know the area, which would be length times width, is 24.5. Now, we could solve this algebraically if you want to, but what I wanted to show students is if you ever get stuck on how to solve something and you have your graphing calculator, you can use that to help you by plugging these into your y1 and y2 and find where they intersect. Now, if this is slower for you, especially after we practice using the online calculator, obviously this one you can algebraically solve. It'd just be a quadratic, so you'd have to try and factor, or quadratic formula if it does not factor. I just want to show you how you can use your calculator here. So now for my window, careful because this is normally it's defaulted to like -10 to 10. But I want to know when this equals 24.5. So that's going to be graphing a horizontal line. So I'm going to go all the way up to 30 here. And there's my graph. Now, if I'm trying to find the length here, this intersection point wouldn't make sense. I have a negative length, so I need to calculate this intersection point. Our calculator can do that for us. Second calc, intersect is option 5. First curve, toggle over to the intersection point. Second curve, where they intersect at 7. Okay, so when L is 7, so for perimeter, I would do 2 lengths plus 2 widths, which is 7 minus 3.5. Honestly, I'd plug all that into my calculator and I'd get 21. Okay, good deal. Next one, number 2. You okay? That sounded like it hurt. A tank is in the shape of a right circular cylinder. All right, so circular cylinder, and this is a right, meaning it's standing straight up, like so. It has a radius of r, and the height is 3 times the diameter. Okay, I'm just kind of jotting down as I go here. Which of the following would be the volume? To find the volume of a cylinder, and for any really polyhedron, you just take the area of the base, area of that circle is pi r squared, times the depth or times the height. Now, looking at my options here, my volume is only expressed in terms of r. So I basically need to find a way that relates my height to my radius, and that was why they gave me this piece of information. My height is 3 times the diameter, and I know my diameter is 2 times my radius, so the height is 6 times the radius. So if I plug that in to my volume formula for the height, I get 6 pi r cubed d. Okay. Number 3. This is almost like an Algebra 1 type of problem. The cost of 3 granola bars and 2 bottles of water is $7. The cost of 2 granola bars and 1 bottle of water is $4. How much does each item cost? I have 2 unknowns. How much does a granola bar and how much does a bottle of water cost? And I have 2 equations. This is a systems of equation. This, 3x plus 2y equals 7. This, 2x plus y equals 4. I'm letting x be the granola bar, y equals a bottle of water. We didn't actually go through and solve this one because I said there's a lot of ways we could do it. Classic substitution or elimination would suffice, it'd be just fine. You could solve these each for y, graph them, see where they intersect, or you could use our new learned strategy of matrices to solve this. But you get the solution 1, 2. X is my granola bars, Y is my bottle of water, so C. Oh, just kidding, sorry, B. B. And we'll circle the one where the water's $3. B. Okay. Next problem says, how many solutions does this equation have? Trigonomic equation here. I have my graphing calculator. I'm not going to waste my time trying to solve this algebraically. I'm going to plug this into my y1, see where it equals 0, aka where does it cross the x-axis, and I'm only looking from negative pi to pi, so I'll adjust my window to do that. I reminded students that, hey, if you're graphing trig functions, we must be in radian mode. Right now, my calculator is telling me it's in degree mode, so I'm going to go ahead and switch it over to radian. Go to my y equals. I'm going to graph x squared, cosine of x squared. Again, I'm only looking from negative pi to pi. And I'm only looking for where it equals 0, so where it crosses the y-axis. I'm just going to kind of zoom in around my x-axis like so. All right, so I just have to count how many. 1, 2, 3. This counts as 1, 4, 5, 6, 7. Here's also a good example of one where you might have to type in a numerical answer. Might not be multiple choice, and the CLEP is formatted that same way. All right. I love the next problem. This is one kind of similar to what I would give you on this assessment. Carter began walking from a campsite. He walked 2 miles due east. That'd be this direction. Then he walked 4 miles in the direction that was 45 degrees east of north. All right, let me put a little compass here to give us some direction here. 45 degrees east of north would be this direction. No, I'm saying, where did you get 45 degrees. And this was for 4 miles. So this obviously forms a right angle right here, meaning this entire angle would be 90 plus 45, 135 degrees. We want to know how this is distance from the campsite in miles. This is a SAS, a side angle side setup here. Since I don't know any angle opposite side ratios, law of sines is not an option, and SAS setup is law of cosines. Law of cosines will be given to you. So I need my unknown side squared equals my 2 known sides squared. So 2 squared plus 4 squared minus 2 times those sides times the cosine of the included angle, which is 135 degrees. All right, I have my calculator, and I'm noticing that this angle is obviously measured in degrees, so I'm going to have to flip back over to degree mode. Don't forget to do all this. This one's pretty simple to solve. We just plug and chug. 2 squared plus 4 squared minus 2 times 4 times the cosine of 135 degrees. So that's x squared, so I got to square root that, and I get 5.6 miles, which is option E. Okay. The next one, so those are calculator practice ones. The next ones would be types of questions that you would not get a calculator for. So let's look at number 6 is a piecewise function. All right, so you guys all know your homework for 16 problems? Okay, use the YouTube videos if you need them. All right, so I have a piecewise function here, a linear piece and a quadratic piece, and they're asking me for the range. So I'm going to probably draw a little picture here. It always helps to have a visual. And what I like to do is I like to look at the little break here and figure out, okay, where does my line start here when x is 1, and we get out 3. And since that includes in my first piece, I'm going to do a closed circle. So then for everything less than this, everything to the left here, I have this negative sloping line. It doesn't have to be super accurate, just something like that. Slope of -2 doesn't have to be super accurate.
And then you should let us take
This piece, when x is 1, we get out -2. Open circle here. In this piece, every time x is greater than 0, so to the right of this, I have a quadratic, a U down or a sad face parabola, so it looks something like that. I'm just finishing up a recording quick, guys. All right, so what is my range? Intro notation here. We see it's everything from negative infinity up to -2, not including -2, and then everything from +3 to infinity.
Can I be in here?
Yeah, I just forgot to record, so I'm just finishing this up. I'm just doing these 10 problems. Pre-calc, CLEP, prep. All right, number 7. This is probably more of something you would have learned in Algebra 2, solving an equation, a rational equation. So when your unknowns are in the denominator, we have a complex fraction here. We got fractions within fractions. So I'll just kind of walk you through. There's a couple ways you could do this, but I would personally, since I'm dividing this side by all that jazz, and times both sides by that. And that gets rid of that. So then I have 4 minus 3 over x plus 10 over x squared equals 3 plus 4 over x minus 2 over x squared. So then I asked students, like, what are some ideas to solve this? I heard combine like terms. I heard find common denominator. They said those would all work. The quickest way to do this, and probably what you learned in Algebra 2, is to find the LCD of all your fractions here, which in this case is x squared, and times both sides of your equation by that LCD, and you will clear all the fractions. Watch the magic happen. So x squared times 4x is 4x squared. X squared times 3x is 3x. X squared times 10 over x squared, those would cancel and give me 10. Okay, after I showed them this, they're all like, oh yeah, I remember. I just need like 5 minutes, guys. Okay. 3x squared over here plus 4x minus 2. And now I'm left with a quadratic equation. This one is nice. It ends up factoring nicely. We get solutions of 3 and 4, which is E. I just told students with these sometimes be careful if you get a solution that's in your restricted domain. So looking at my original equation, x could never be 0. So if I would have gotten a solution with 0, there might be an option that includes 0 and doesn't include 0. So just be careful with that when you're solving rational equations. It's not in our domain. Okay, I really love the next problem. We have a sine curve, and they want to know which of the following intervals is f decreasing. Okay, so this sine curve has an amplitude of 2, which means it does not go higher than +2 or lower than -2. And then what I kind of taught you was to take whatever horizontal transformations are going on, set up the normal period for sine, which is 0 to 2 pi, same as cosine, and then solve this for x. And this applies to horizontal transformations too. So you can see here we got a horizontal stretch. So my new period is going to start at 0 and end at 6 pi. Okay, so then I asked students, where does sine start? Does sine start at a 0 or at a max? And if you don't know, think of what the sine of 0 is. That point is 1, 0. Sine of 0 is 0. Starts at a 0, ends at a 0. Sine curve goes like this. Halfway is a 0, halfway, max, and min. There's a sketch. They want to know when is sine decreasing. So when I read this graph like a book left to right, when is it going down? This piece. So I do need to find these halfway points. Halfway between 0 and 3 pi is 3 pi over 2. Halfway between 3 pi and 6 pi is 9 pi over 2. So it's in between 3 pi over 2 and 9 pi over 2. D. No calculator to be given to us on that.
31. I'll be
All right, now, conic sections are normally taught in pre-calculus. You guys learn them in Algebra 2. So it might feel a little, well, it's the last thing you learn in Algebra 2. It's the last chapter we cover. So it might feel like it's been a while, but I'll try to refresh your memory. And if we need to review over conics more next week, we can. So which of the following is an equation of this figure? This figure is an ellipse. Now, just looking at my multiple choice options, option B, that's an equation of a circle. And then for D and E, when there's a minus in between the x and y squared, that's a hyperbola. So my really only options here are A and C. Here's your generic equation for an ellipse. So where H and K are my center, and they're always set equal to 1. And then depending on which this direction goes, A squared is always like the larger value, if you remember that. So this is what I call like a vertical orientation or like a vertical type. So A squared would be under the y squared, and A is the distance from the center to the vertices. So here I see that's 3. And then B is the distance from the center to the co-vertices, so that's 2. So in this case, it would be A, it's centered at 0, 0. B is 2, A is 3.
Oh, yeah.
Okay, sorry, last one. Ooh, log equations. This one, students were a little rusty, so we need to practice our logs.
How much would that be?
8. So here, the steps for log equations is first you kind of condense your logs if you can. Like if you have 2 separate logs on one side equation, you condense them to 1 by either using the product or the quotient property. Here, I have a power property where I have this number 2 in front. So I'm going to put it back as a power. That's called condensing. Okay. So then I asked students, what's the inverse of logarithms? Natalie Z confidently said exponents. And I was like, yes, ma'am, exponents. This one's a log base 10. It's my common log. So I'm going to exponentiate both sides with a base of 10, and that undoes the logarithm, inverse operations of each other. So I get t squared equals 3 minus 2t, ends up being a quadratic, which factors into this, giving me solutions of negative 3 and 1. Now the answer is not D. Some of our students forgot this. That our domain for logarithms is only positives. All right, here's why. Think of exponential growth, looks like this. Exponents, the domain is all real numbers. In our range, we only ever get out positive numbers. Logarithms are inverses of those. So the domain is only positive, and the range is all real numbers, and our graph looks something like this. So if I look at negative 3, and if I were to go to plug that back in my original equation, right here, I'd be taking the log of negative 3. I know we don't have our calculators, but if you were to type that in, it would say domain error. Can't do that. So it's actually 1 only C. Okay, I actually forgot to record when I was actually teaching this, so I just did a quick little summary for you guys. Here's your homework. I gave this test to you guys before you left. So I'm splitting up that practice test into 4 assignments. So your homework for Monday is to do the first 16 problems on here. They're all calculator practice. The answer key is the last page of that packet, so you can check as you go. Oh, just kidding. Is there an answer key? Maybe there's not an answer key. I will have to look. I think there should be one. What I also showed them, what I want to show you, is I found this YouTube playlist of some random guy going over each question. I watched a couple of them to make sure they were like good explanations, and they were pretty good. And he even like kind of goes over some test taking strategies for the CLEP. So I told them if you really, really get stuck on one, obviously try it first on your own. But if you really, really get stuck on one at home, you can watch. They're just short, like 1 to 2 minute clips. Like, oh my gosh, I have no idea how to do 15. And this can kind of help you at home. It's basically the same of you coming and asking me for help. So use that to help you. Best way to study is by doing practice problems. And next week, Monday, Tuesday, Wednesday, I'll be doing more practice problems in class.